Hello and welcome to the Omnex webinar, AIAG VDA FEMA Problems and Solutions. Today's presenters are Chad Keimal, Omnex CTO, and Greg Brusca, FEMA Champion for Omnex. Chad Keimal is the CTO and founder of Omnex. Chad attended General Motors and for a number of years worked at General Motors and KPMG before founding Omnex in 1986. Over the course of Chad's successful career, he has served on the Malcolm Baldrige Board of Examiners and received numerous quality achievement awards, including the Quality Professional of the Year award awarded to him from the American Society for Quality. Go ahead, Chad. You can take the webinar away.
Miles, thank you very much. Welcome everyone to the webinar, the second in our series on AIAG VDA FMEA. We had a webinar a couple of weeks ago with three of the writers of the FMEA standards, two from the 4th edition, one from the AIAG VDA FMEA. Actually, three from the 4th edition, and one of them was also on the AIAG VDA 1st edition. I'll introduce Greg to you in a more detailed way just shortly. He's got a very rich background I'd like to let you know about specifically for this subject. So let's get right to it. Today's webinar, as you know, is an hour and a half because there's a lot of questions. In fact, from one of the webinars I did from Quality Digest, we could not get to a lot of questions. We're going to take all those questions in this webinar. All right, let's start. Folks, a couple of things I'd like to let you know about us as we go through. If you're new to who Omnex is, we're a 33-year-old company headquartered in Ann Arbor, Michigan, who has done a lot of things for about 5 different industries. Of course, being in Michigan, headquartered in Michigan, a lot of work in the automotive industry, and we do a lot of work currently and in aerospace, medical devices, semiconductor, high tech, and so on. All right, we're very global, and we do the very same training. This training that AIAG VDA training that we have launched is being done globally in China, India, Europe, and Mexico. All right, so here is the AIAG VDA FMEA. I just passed the abstract and what we said we'd talk about. I want to make a small little correction there from Miles. I went to General Motors Institute, and a lot of us who graduated from GMI take great pride in GMI, and also today known as Kettering, by the way. And as you might expect, with my background, I've done a lot of work in FMEAs. In fact, it's one of the core items of what I started doing in the 1980s, working with though I had a General Motors background, I worked with Ford Motor Company's Q101 standard, which I still love dearly, and it made a major impact in the automotive industry. So let's talk a little bit about Greg Brusca. He's been on the writing committee of several of the core tools manuals, but really something interesting is that Greg, similar to Mike Down, and I haven't talked to Mary Rousey in great detail, but I think all three of them who are writers of the FMEA standards had worked very closely with Dr. Deming. And you can see Greg still getting invited to plenary sessions when they talk about Dr. Deming, last of a dying breed. But I also would like to let you know, some of the things we who have sort of grown up in the automotive industry know is that his book, Greg is right here, so let me ask you, Greg, I forget is it CP squared?
Yeah.
And that stood for?
Comprehensive Process Control Planning.
All right. Folks, you don't know this, but that book and then Greg's support of the DCP methodology at Ford Motor Company really changed the way FMEA's control plan work instructions were linked. I'd also like to take a little credit. At the same time the DCP was coming out, we also had identified the linkages between process flow PFEMA control plan work instructions, and we wrote our class called Process Review, which is still called Process Review so many years later. And that time, though, the idea of Process Review was working on existing products. I'm going to tell you a lot more as we go along. So I think, there's a lot more I should tell you about Greg, but you can sort of read it. Our AIAG VDA champions are also very much into functional safety, ASPICE, and all the different standards coming out with the e-car and autonomous cars. All right, let's move on. Here is today's agenda. We're going to do a quick introduction to the AIAG VDA FMEA. Now, we do have a few new people coming in. If not, I would have skipped right in and gone to the next section, but we have a very short intro. And then we'll talk about the problems and solutions that we see with the AIAG VDA FMEA. And then we'll specifically talk about the AIAG VDA process FMEA. We don't want that to be left out. Quick summary, and I hope we can spend about half an hour on Q&A. In the very outset, let me just tell you that how pleased we are with the AIAG VDA FMEA methodology. We are very supportive and think in the summary you will see why it is we are so much in favor of this 7-step approach that is very much needed as the industry moves towards electric cars and autonomous cars. All right, let's move on. So, introduction to the AIAG VDA FMEA. If you didn't know and you're listening in for the first time, just to let you know that the project coming from two different, one from VDA in Germany and from the AIAG here in Southfield, Michigan, was to combine two different formats of FMEAs into one format. What's the big deal? Well, actually, it's a big deal. The large tier ones and the OEMs are global players, including now you're seeing second tiers being global players. They're global players, and there's a big, issue in that the German design engineers and manufacturing engineers have an FMEA that's not compatible with the other large part of the automotive industry that's in the US. And in countries like Mexico and China, where both parties are very strong, that is the German OEMs and the American OEMs, there's multiple formats people have to do things in, and it's very confusing, and it's non-value added. So, team members from the OEMs and tier ones from Germany and the USA worked together, really folks, for 3 years, and finally released June 3rd, 2019. All right, so this is a slide just saying what is it we're looking at. There's a failure that's a cause that fails, that affects the failure mode, that results in a failure mode that results in an effect, okay? All right. This is the basic methodology of both formats, and they haven't changed. At the end of the day, what we're trying to do is to best understand the risks involved in these linkages. And there are fundamental changes, folks, in terms of where we put the effect, where we put the cause in the AIAG VDA FMEA that we'll talk about. Greg, did you want to say anything more? I know this is one of the slides, but the fundamental cause and effect has not changed. Am I right?
Yeah, one of the reason why we use this slide is that in the past, people not understanding this relationship when they were coming up with the cause in the form, since the effect was the column that's immediately to the left, often gave causes of the effect, which was definitely inappropriate because the failure mode is the cause of the effect. And consequently, they had inappropriate analysis because they were not looking at the relationship, the cause failure mode effects relationship correctly.
I'm going to say a little bit more. I just recently met and talked to a young engineer. He's an American engineer, but works for one of the German tier ones. And the thought is, it's just a FMEA. How difficult can it be? And I said, it's fraught with difficulties. And the quality of the FMEAs we see, leave much to be desired. All right. So, today it's not about critiquing a filled out FMEA. We're critiquing and evaluating this AIAG VDA FMEA format that's been presented to us. In fact, here are the 7 steps of the AIAG VDA from the AIAG VDA FMEA handbook, right from planning all the way to the results. And what can we say? Well, it's the same process for both the DFMEA and the PFMEA. Here on the very top, you see the 7 steps. Here is a form we took from the AIAG VDA FMEA itself. And it's a good summary sheet to have. And you look at the very top, it says systems analysis, failure analysis and risk mitigation, and the 7-step communication.
Yeah, the last part is one of the new requirements in the handbook. The previous processes really did not require or advocate the summary report of what was going on. It was assumed that the FMEA itself and the activities involved with it would be sufficient.
So I want to comment a little bit, Greg, on the 7 steps. To me, it is very similar to the 8 disciplines of the 8D, and that it's not that we didn't know problem solving, but when we came up with a very strict sequence of how something should be done, it really helps to do things right. And I think the same goes here in terms of having a step 1, step 2, step 3, and having a little bit of a recipe for doing it. Of course, as Americans, we may have a little bit of a hardship, and maybe you'll think of a loss of creativity, but hold on to that thought. We'll bring that up in terms of as we delve a little deeper. All right, here's the first issue. So in yellow here, we try to identify the issues. What can we say? Gosh darn, the form is really long. And, we'll show you maybe in the next slide that the relationship is 3-dimensional between something called the focus level, the higher level, and the lower level. Look at the colors, folks. Do you see that the structure analysis is 3, functional analysis is 3, and failure analysis is almost 3? Well, that's because all the way to those 3 columns, they all belong to different parts of the bill of materials, if you want to say. Okay. And one of the questions I had actually in the last webinar, as soon as we talked about levels, people didn't know what we're talking about as a level. So the focus level is typically your product. Okay. The higher level is the system your product is going to go into, which belongs to your customer. The lower level are components of your product. You either could be making it or a supplier could be making it. So in a very simplistic way, if you thought about, you have a subsystem that goes into a system, or, that has components going into it. That's the focus level, higher level, lower level. All right. But here, the point we wanted to make is a form is long and not easily supported in Excel. That's the first, issue that we wanted to talk to you about. Next, what we wanted to say is just again go through the first step. And one of the things you can do that you'll find out in the first step, you have to do the 5 T's. You can put the 5 T's right in the header itself, right? And then you do the structure analysis. The structure analysis is really the BOM itself, the bill of materials, okay? It's called the structure analysis, is what the Germans called it. And then you identify the functions and requirements for each of the structures that you're looking at, or the products you're looking at, the higher level system, your subsystem, and then components at the lower level. And then you have failure analysis, and then you do a risk analysis, okay? And then you do optimization. Optimization is the recommended actions coming out of the action priority step in the risk analysis. So RPN is being replaced by action priority. And then, of course, you have the 7-step results documentation. And again, other than the form being very long and being very specific to guide, the person filling it out, we can also say having a disciplined process for a FEMA is not a bad thing. And any other comments you want to make, Greg, before I move on to the next slides?
No, go ahead.
Okay. All right. So the point here is we're going from 2-dimensional to a 3-dimensional form. Here is something that could be done by Excel, and then we have this a 3-dimensional form because you're actually got 3 levels of the same product: the subsystem, the system it goes into, and the components that go into the subsystem. And then you can imagine all the functions of it and the different relationships between the functions, higher level functions and the lower level functions, okay? Which is sort of a, the higher level system function is being met by the subsystem functions of your product and being met by the lower level subsystem requirements, subsystem requirements, okay? So that's sort of the architecture underlying this, which soon as you get into a complicated product, I think if you take a simple product, we all believe Excel will work. But soon as it gets to be a little bit more complicated, Excel is not going to quite work.
Yeah, that's true.
All right. So, I don't want to bring it up as a problem. It could be a problem or a benefit. What do we know? Well, as we were discussing it, Greg was mentioning it's not going to be a problem getting suppliers involved, right? If you're the focus level and the subsystem, for now in this discussion, let's say we're all tier 1s, all right? As a tier 1, we can always get our suppliers involved, but how the heck do we get the customer involved? How many of us have ever gotten a DFMEA from the customer? All right, so it's a problem, and that's what we're bringing up here, that the methodology requires function analysis and failure analysis of the system, subsystem, and component. Knowledge of the system and component is questionable for the cross-functional team that really knows the focus level, or the tier 1 really knows its own product. Does it really know the product of the supplier? And does it really know the product of the customer? Well, this is going to force that. Well, the problem will be if one of those levels are not cooperative, right? Okay. So what are we saying here? We're saying even in making the change with the supplier, we have an implementation class that we talk about where we think the new product development process of the tier 1 new product development / APQP process, the tier 1 needs to change. And it needs to change and be cognizant about parallel development between customer, ourselves, and our suppliers. So it's not just, where do you, interject working with a supplier in your, new product development process. Is understanding there's 3 new product development processes going on. And folks, today, with the mechatronic systems we're talking about, we have the system being made, subsystem being made, and you have hardware and software that's getting developed. So it's a very complicated environment that we have, and these levels all need to work together. All right, so the point here is collaboration between customer, supplier, and sub-supplier. Go ahead, Greg.
Yeah, one thing we've got to give credit to the handbook is that every step they have a section on talking about collaboration. Collaboration, both internal collaboration between the different engineering disciplines, as well as collaboration between the customer, supplier, and sub-supplier. So they do recognize that you need that type of involvement. However, the practical point of it that Chad was getting to is that it is specifically with respect to customer, it is very difficult. Experience that we have had with the standard ISO 26262, which explicitly has requirements for customers as well as the supplier, shows that the customer doesn't always read the standard or do what the standard wants. And so
basically they say, here's an ASIL B or ASIL C. We're not getting safety goals. We're not getting safety requirements.
Right.
Something as simple
and
as
DIA.
that. Yeah, distributed. I am seeing DIAs, but it's bad DIAs. But folks, that's another standard, but it's the idea of this collaboration that really needs to improve.
Right.
All right. So I'll just make one more comment. The next revision of the AIAG VDA FMEA, I hope they talk a little bit more about where the industry is going with hardware and software. I have not myself delved deep enough into the MSR to see if the MSR, but I think it just needs to be there in the structure analysis. We need to go as far as hardware and software. And of course, folks, that's what we're going to be telling you, as we work with you in these mechatronic systems. All right. The next problem and issue that we want to bring up and talk to you about is that the standard says, the handbook says, you can either do the block diagram or you can do the structure analysis in the DFMEA. And what we'll tell you is you have to do structure analysis or you lose this focus level, higher level, lower level in the DFMEA, which means then we're going to say you have to do a boundary diagram also. And then we have the P diagram, and then we have the interface diagram. Greg, why is the interface diagram become really important when we do AIAG VDA FMEA?
Well, if you are only using the structure tree, you really do not clearly identify the interfaces between the different elements within the product itself. And when you're looking for a systems in FMEA, the primary or one of the major differences between a system FMEA and a design FMEA is a system FMEA recognizes and identifies and discusses interfaces, where a design is looking internally, it doesn't look at externally. Consequently, when you are, if you're not displaying it, if you're not clearly identifying it, then the chances are you're going to miss things that could affect you adversely.
Folks, when we look at the current DFMEAs, for better or worse, let me just say the 4th edition DFMEAs, our customers didn't really do a good enough job focusing on the interactions between the components and coming up with the interface functions. So Greg, there is a initiated passenger airbag with a 2 correlation with the control unit. It's a +2. So what should the DFMEA have then in it?
Well, the DFMEA, when it's looking, what would be a failure mode? Well, a 2
Interface
says the
function,
interaction is
Yeah.
necessary for function.
Yeah.
So if I do not have full interaction, I am going to have a failure mode. And so we have to start asking the question, how are we going to assure we're going to have full interaction between those two components?
Let me just also add, Greg, you need to have a function called initiated passenger airbag control unit interface function. Okay, if you you can just go pedantically like that to where there's a correlation, you have an interface function, and you have to populate your DFMEA, and that's why an interface diagram is important.
Yeah, as it turns out, the practitioners of the process, FMEA process, say, well, you can always add it, and that is true. It is valid. The problem is which interface or what interfaces do you have to add or identify, and which ones do you want to do you not? For example, control unit to the front sensor from a physical touching, you don't have to have any concern on it.
Zero.
Right?
Yeah. Folks, we really believe in the P diagram also, but we're just going to call it optional. So in the model that we are proposing, you have to do boundary diagrams and structure analysis. You can choose between the two. It's not optional. And we do believe interface diagrams are also highly recommended from Omnex, so much so we put it in as a requirement. All right. So why only 3 levels? And Greg, do you want to take over the presentation from here?
All right.
And we'll discuss the issues at hand.
All right. The FMEA process as given by AIG VDA requires at least 3 levels. The higher level, the focus level, the lower level. The problem is, in this case, we have 4 levels from car, safety, airbag, ECU. If we only looked at the 3, the safety, airbag, and ECU, the upper, lower, and the focus level, for focus was airbag, we may not look or identify what are the risks of a problem in the vehicle itself.
Greg, I'll just say this. For many of our customers today, because of where the industry is going, there are more levels below the ECU. In fact, I was working with a customer this week. They went from the system right to the hardware, and they put all the components underneath the hardware. So the ECU will have lots of components, or maybe it's a circuit board, and that'll have lots of components. And somewhere in there, we need to actually put software also. But go ahead and continue.
All right, well, then that gets on the other side, is what is the root cause, as it were. If according to the approach, the cause of a focus level failure mode is a component level failure mode. And so the only thing we could say is that the ECU is non-functional, but it doesn't say why does the ECU non-functional. Why are we getting an airbag problem?
We have 2 examples in the next 2 slides, and we can discuss it a little bit more. But I'll just say this. Why are we bringing this up? We're saying the real life has 5 or 6 or 7 different levels from womb to tomb. And in all the examples, because, we have a strong FMEA team in Germany who's been doing these VDA FMEAs for a long, long time. And we only see 3 levels. So, rarely do we see somebody, going down to a lower level than a lower level. That's the point we're trying to make. And what happens if you focus on only 3 levels, Greg?
Well, the FMEA team will jump multiple levels to what they think is the real cause, rather than just focus on those particular 3 levels. That's in the current approach. With the new FMEA, all the failures must be at the 1 level down. Now, we can say that one of the positive points is that we identify a flow down, which makes it easier to see the requirements flow down. But when we don't allow the jumping, or when we don't have the jump, it does have some negative points. One is that you need additional documentation. You need additional analysis. And if we have the DFMEA where we're only restricting ourselves to 1 level, are we really controlling the right root cause?
And that's the point. So if you go step by step, you're going to have lots of documentation. Number 2, we would say, hey, when I was doing the AIAG 4th edition, I was going right to the root cause. Maybe it's way down, to the component level, 3 levels down. I'll just go identify that failure as causing it. And that's the rub here, And I can't say one is better than the other, but you do lose something when, in between the two.
All right.
Okay. Let's look at the other side of it. So this is a lower level issue. What about the higher level issue?
All right. Again, that gets to, if I'm looking at where we're looking at the safety systems to the airbag, I really do not look at what is happening in the vehicle itself. Now, from the matrix form that's in the handbook, they recognize that, and they include it in one of the in the column. At the higher level, they put and or the user. However, it doesn't say how do you do that if you're not using that Excel-based form. In there, how do you even get that final user when you're only looking at 3 levels on it?
Okay, so folks, that's the idea and thought behind, why only 3 levels. If you don't only do 3 levels, which is meaning you just do it at a subsystem level, what do you lose? All right. The next issue is a more of a serious issue, and I'll take a first stab at it and let you go at it, Greg. When you look at all the different examples in the AIAG VDA FMEA handbook, and you look at all the examples, we know how our VDA, partners in Germany work. Greg and I, frequently interact with who is considered one of the topmost FMEA specialists in Germany, and we've had this dialogue maybe starting with 2013 when we did a couple of symposiums with him. The AIAG VDA looks at the failure cause always at the lower level. That's the way it works. And what we want to say is, look, folks, when the Americans did design FMEA, we tried to improve our current design. So a lot of causes are at the current design. I'll let you take over, Greg.
All right. And again, with the core tools FMEA, one of the things that was spelled out is that when you're looking at cause, what in the design process could cause a missed design or misdiagnosis of the design of the product we want. So some of the possibilities is that we did not understand the use case. We didn't include all the expected stresses that the product was going to be exposed to. We didn't communicate that to our suppliers to the lower level. So instead of just saying that the failure cause is this particular component, that the component is not correct, we don't really get into the problem is not really the component isn't correct. The problem is I did not communicate properly to the supplier what are my needs.
I having worked with, just it's sort of a designer mentality, and especially, I don't want to say a German mentality. It says, hey, my design, it's perfect. Yours, I don't know, but mine is perfect. Let's not even look at mine because I'm perfect. Anyway, that's my joke. All right. So, failure analysis. I knew everyone would blame me. Pass the buck downstream. Okay. We already talked about it a little bit. That's what we think is happening with this model, and it will bring it up as a problem, and we'll come up with a solution. Anything you want to say here?
No.
Before going? All right. So this is the solution we propose, is that the model needs to be changed where the first thing we think a design team needs to do is look at the causes at the focus level. Then let's look at the cause at the lower level. Doing this exercise, folks, it doesn't happen like that. We come up with both lower level causes and current level causes, but the model needs to understand it. And of course, the software that you end up using has to follow that. So we offer this up for anybody to use. We just ask for a citation if you do use the model that we're proposing. And you can see the writing on it because we also do have software. We just want to make sure if any other software user is going to do it, software company is going to do it, we'd like to give them written permission to use it. All right. Okay, this is also another big issue, a key industry issue the 7 steps does not address that we want to make sure they address. Go ahead, Greg, if you want to say, and I'll maybe make some comments in the very end.
All right. The DFMEA, well, let me step backwards. The I can't even remember, 16949 says that you have to identify special characteristics during the design activities, which are then communicated to the processing people who then augment it and finalize it.
And nobody's doing it.
And
nobody's doing it.
Nobody's doing it.
Nobody's
right.
getting it from the design folks where they should come from, and it should be based on rules. But go ahead.
Right. Well, as it turns out, again, DFMEAs deal with functions and not characteristics. So the approach, and we've got to give Ford Motor Car Company credit for it, was one that advocated this, is to identify special functions. A special function is the function equivalent of a special characteristic. The key thing is that once the design in a DFMEA identifies special functions, then there needs to be at least one or more characteristics related to that functionality that then become special characteristics.
Greg, I thought I came up with this. You're telling me Ford did?
Yeah, Ford did, right.
All right.
Well, they have the Y, Z, and Y, whatever, on the DFMEA. The thing is that the handbook does have a couple of sentences. It seems like it's more of an afterthought because in the DFMEA there is no column called special functions or special. What they do have is an extraneous comment column for formatting, and they put a comment in at the end of the book that if you're going to do it, you can use that column for identifying. But it is not part of the process. No place.
And we think it's got to be a part of the discipline of doing a DFMEA. And we got to call it out, and there are rules behind what is a special function, and then the team has to go and identify the special characteristics, and we'll show you where a little bit later.
All right.
Okay. All right. The next is a very key idea and thought, and this is where I want to make the point. I think the AIG VDA FMEA is great. It's a move in the right direction, and it's a move in the right direction really because of e-cars and autonomous cars. All right. So what do you need to do? It requires you to come up with cascading requirements between system, subsystem, and components. Unfortunately, it's a cascading set of functions the way it is practiced today in the VDA community. The handbook says you could have functions and requirements, and there is a section on functions and requirements, and Omnex will say it's not optional. You have to mandatorily do functions and requirements. Why? Because it's ASPICE requires it, 26262 requires it, the cybersecurity standards require it, and SOTIF requires the engineering V. Let me just show you the engineering V so you understand it. If you want to get this flow down of requirements from the stakeholder, that's the higher level, to the system, which is a lower level, focus level, to the subsystem, which is the lower level, and then focus on the lower level and getting it into hardware and then into software in a second level DFMEA, you've got to do functions and requirements. What else is missing? What else is missing is this whole idea of test plans on the right-hand side. So, folks, I don't know if we came up with the idea of the linkages between process flow, PFEMA, control plan, work instructions in the mid-80s. Somewhere in there, we have this picture. I don't know how far it goes back to in the, maybe it is when Dave Watkins joined us. I forget now, Dave, when you joined us. Dave Watkins and Mary Rousey are in the room next door. And we have this wonderful picture, this picture that shows the design on one side and the process FMEA on the one side, shows the control plan and the PFMEA linkage, and it shows the DFME and the DVPNR linkage. So it is something we have practiced for a very, very long time. It's a miss. This is a great opportunity to link the DFME and the DVPNR. The industry needs it, and it's a problem.
Right. The handbook does not even address DVPNR and does not address control plans.
So if you're coming up with a 7-step discipline, folks, it's missing. So what do we need to do? What is the solution? We think 2 changes need to be made to the AIAG VDA 7-step process. During function analysis, we need to put down functions and requirements, because then they'll automatically link down, okay, and link up. And you also need, as a final step of the 7th step, you need to connect the preventive and detective controls to the test plan or DVPNR if you want to have this V now really required. Folks, someday, someplace, if you want to, I'll tell you all the issues. If you don't have it, it's a real issue. All right. So this then is the last slide for the DFMEA, and then we'll pick up the PFMEA. These are the steps that we think is required. Of course, 5 T's are already there. And then in structure analysis, this is the idea you need to do really 2 things, which is you need to do the structure development, which you have to do, boundary and block diagram, and interface diagram. That's what we covered, right? Earlier in the slide. Third is that you have to have functions and requirements in step 3. Step 4, causes should be on the focus level before causes on the lower level. Again, in a creative process of how our brains think, it'll come up mixed, but don't forget, easiest for us is to improve our current design before we tell somebody else to improve their design. Okay. And then we have 5B. As soon as you finish risk analysis, you need to link the special characteristics and pass it on to the process flow PFEMA control plan. But the nice thing, Greg, is the handbook does say when you do the PFMEA, link back into the design, right? It makes you look at the failure mode and identifies the functional design failure. But folks, it needs to come this way first. Don't leave it up to the manufacturing folks to tell you, what in the manufacturing fails a design. We need to be thinking proactively and populating this. And then we have the final 7B step linking to the DVPNR. This is what we'll propose as a 7-step DFMEA process that we will allow anybody to use. Just put down where you got it from and so on. All right, next what we'll do, we'll talk about the AIAG VDA FMEA, process FMEA, and let's start here with the manufacturing process flow example. This causes Omnex a lot of heartburn in that this is actually something that came from the DCP, and of course we've embellished it further. You know, what a beautiful process flow example that we think is best in class. Operation number, description, and it goes womb to tomb,
Right.
all the way from receiving all the way to shipping. In fact, I think there are CSRs that say, that you need to have inspection and rework, and
Right.
it also says you need to, so these are all hard-won battles that we have gone through in getting things. Why do you need this kind of flow diagram? Why don't we just show one operation 20?
Because the PPAP says you got to look at every path through the process.
The streams of variation, right?
Streams of variation.
Yeah, streams of variation. And a pictorial tells you also the manpower used, so you can better come up with the failure causes, right? The 4M. All right. And then you see the product and process characteristics, and tells you this is the link between process flow links the PFME and the control plan all together, right? Okay. And you can see here process characteristics and so on. Sources of variation. Again, something that came all the way from DCP.
Right.
What year was that, Greg? I feel like it's like only 10 years ago, but it's more
84, 85.
1984, 85. Amazing. I do recall writing our first Omnex Navigator about that. And I don't know, shortly thereafter, I think you and I met. And you hadn't first started working with us maybe till a couple of years later. All right, this is what we think is the best-in-class approach. And this, of course, is a structure tree with the process steps and the 4M, 4M1E, I would think. And the lowest level in the PFMEA structure is a man-machine method materials, all right? Sort of a little bit of a cause and effect between the failure mode and the failure causes. And this is what is being proposed as the 3 levels.
Right.
On the left-hand side is a line, manufacturing department, manufacturing whatever.
Well, it's actually
it's
the
a
product.
name.
It's the product that you're producing. That's where you get your
Yeah, but
product
even so,
failure
it's a manufacturing process line, right? Which has these process steps, and which has got the 4 influencing factors is a 4M. And one of our other writers of the FMEA he gets really upset, and he says he doesn't show a flow, hard for the shop floor to understand. He thinks the shop floor will just not get it, and does not show the different operations, how many machines, i.e. complexity. Okay? And I thought I would capture his words here in yellow here. So the structure analysis and process flow are shown as optional steps. Here, you can actually skip the structure analysis and just do the process flow. In the DFME, you can't get away with it because you need the structure analysis. But here, the structure analysis doesn't really matter as much. In fact, I went as far as saying they were just trying to be pedantic, if that's the right word, between the 7-step DFME and the 7-step PFMEA. Folks, maybe at a later time I will come back and say maybe it's a good idea to have the same 7 steps, but the only people who will be doing both steps, I think, are consultants. Inside the company, the people who do DFMEAs and the people who do PFMEAs are different people. Do we need to have the exact 7 steps? I like the idea of consistency, but not if it's forcing a false idea. Anything else you want to? Okay, let's go on then. This is what Greg and I came up with in one of the papers we wrote, is a suggested process flow that bridges the gap. You want to comment on this, Greg?
Yeah, one of the problems with the work elements and the functions of the work elements is that when you're doing it in the structure tree, the work elements really depend upon the requirements that you're producing.
Or the characteristic.
Or the characteristic. So different characteristics will have different work elements that affect it or not. So the approach that we're recommending is that you do the process flow where you have the requirements, and then you put in the work elements and the functions of those work elements.
Okay. So this is again the comment with the structure analysis, the linkage between process flow, PFEMA, and control plans are lost. Lack of characteristics of studying detection controls are also troublesome. Okay. All right. Again, we leave this to the public. Our goal is to propagate right thinking, and we just want a little credit because we have gotten so little credit for all the work we have done thus far. You know, I'm getting quite old, and we're all getting quite old. We'd like some, at least some acknowledgement for all the heavy lifting we have done over the years. All right. Let's say this. Why do you have PFMEA? To improve this process. We think, of course, this is going to happen whether you do the AIG VDA FMEA or the AIG 4th edition FMEA. The primary focus is on preventive and detective controls. So one of the things we think that's missing is this linkage to the control plan. Just like the DBPNR, this is a miss, and this needs to be corrected. Also, there's a link to that. Do you see the standardization, the FEMA-driven plan flow controls? This goes back to the 1980s for us, by the way. And that linkage is missing. So very important, in the end of the day, the PFMEA. So one of my friends, one OEM, which I was Mr. Laser Specialist for a long time for General Motors, and I brought in laser welding into GM. So I many friends still in the industry, at that kind of levels, who are actually doing all the heavy lifting. And the disappointment for many folks is that they do it routinely as doing it, and then it goes into their desk. Nobody sees it. Folks, there's no value to a PFMEA that doesn't link to a control plan, that doesn't drive shop floor actions. That's got to be the end goal of what we all do. All right. What did we also want to say here? That, let's go on here. I will say one thing. This is actually came from our Dave Watkins. He liked the idea of the AIG VDA FMEA and structure analysis, but it clearly linked the specific functions that, or requirements, cause requirements, I'll say, that affects a failure mode, okay? And he thought people are a little bit vague today, and he thought this would really help clearly identify it, and maybe we should also just put a link there when we say setup. Click, you can see the setup instructions, okay? PM instructions.
Yeah, you can do that.
Yeah. All right, let's go on. So this is sort of a last couple of slides as we summarize. So discussion on the methodology going to the PFMEA. When you read the AIG VDA manual on the PFMEA side, it seems that you only select portions of the PFMEA. And folks, we are against that. It's hard-won battles. People always try to take shortcuts. This is where we always said the Germans took a lead in design FMEAs, and the Americans always took the lead for the process FMEAs. Let's not lose and get behind. Let's make sure we do a womb to tomb, shipping all the way, receiving all the way to shipping, and all the different rework and inspection stations, because that's all the places where we're getting problems. And that's why the U.S. industry is at almost 0 ppm.
Yeah.
Hey, let's not lose that. So that's the scoping question. We don't think there should be an idea of scoping. Let's do all operations, number one. Number two, structure analysis using the process flow. That's what we think. Function analysis using that process flow diagram in that modified structure we talked about. failure analysis, risk analysis, optimization, or this is the 7 steps we recommend: the process flow diagram and structure analysis, the function analysis as characteristics for the focus level. We don't think you should even populate that function level, but really if you do the process flow correctly with that modified structure, then of course you can, because we've already identified what are the failure causes potentially that drives that characteristic. All right, and then failure analysis, folks, and then we have the 5B, the linkage to the control plan. So here in 5B, it's the planning for what gets affected in terms of shop floor, and then in 7B is the linkage to the control plan and the shop floor standardization documentation. So this is the 7 steps that will work very nicely and very similar to what we have been doing for a long time. All right. I'm going to summarize things, and then we'll go into Q&A, I think right on time. AIAG VDA is a new 7-step process that will appeal to companies who supply European and US automakers. If you are supplying both US and European automakers, it should be a no-brainer. Who have safety products and who are looking for a method to enforce an engineering V. I'll say not only safety products, I'll also say ASPICE, okay? ASPICE also requires the engineering V. We don't know this yet, but SODIF and cybersecurity standards coming also require engineering V. And organizations who are looking to make a culture change internally with the product shift to electric and autonomous cars need to take a serious look at this modified 7-step with the linkage between functions and requirements and DVPNR. All right. Second bullet point. The real ROI is no longer PPMs. The PPM, cost of quality savings, we already have gotten. The return on investment, folks, is in reuse. What the handbook calls baselines, and we're very happy that the what we call in Omnex design and process families, product and process families, are being really touted, and we believe in it. This is the way to reduce by 80% or more when you do a new design, to reduce the costs. We also, from this webinar, want to share with you the problems that we think we need to be solved. Block diagram versus structured tree in the design side, process flow versus structured tree in the process side. Number 2, linkage of functions and requirements to special characteristics, and linkage of DFMEA to DVPNR and PFMEA to control plan and standardization documents. Next, the focus of improvement should be the current design versus the supplier's design. So what do we think? The adoption of the AIAG VDA FMEA with the changes proposed will help organizations improve and accelerate with this era of mechatronic products that require requirements flow down and linked testing and linkage between design and manufacturing. So with that, let me just do a couple more things just to tell you what we have. We have software here at Omnex. We have software for the AIAG VDA DFMEA and PFMEA. We also have free webinars we're going to continue. And folks, to go to the next one and the next one, we think there's a sequence here. The next one is going to be about the transitioning to the AIAG VDA FMEA and what we need to do for transitioning. And then we're going to talk about connecting the supply chain, and the last one is much more software related. So we want to welcome you all to join these webinars, the free webinars that we have, and I hope you're getting value from this one and the last one you attended. We continue a little bit more. some of the training that we have in all different parts of the United States, Mexico, also India, China, and on demand in Europe. Folks, we also have this MSR class written by one of our writers of the FMEA that we are ready to launch. And these are some of the training we have. With that, Miles, what we'll do is we'll start with the questions that we already have. If you could print the rest of them, and we'll take on the newer questions also. So here we have, this is the one about, I hope everybody understood the focus level, lower level, and upper level. Do you want to just explain that again, Greg?
Well, the focus level is the FMEA that you're working on or you're interested in a design. It's the design product or the product that you want to design FMEA on. And in the process, it is the actual process steps that you're going to want to do a PFMEA on. So that is the focused level, right? That's where we're going to do it. The higher level is the system which it supports. So in the DFMEA, if you're doing a subsystem, then you are supporting a system. If you're doing a DFMEA on a system, then you're supporting something in the vehicle itself. In a process, when you're doing a process a focus level, the higher level would be the product that is being produced. You also may have requirements for the process itself, logistics, timing, and those sorts of things. So you will have that.
Greg, take on the next one also. They're saying their company, I won't read the company, in the automotive industry expects the use of several risk management tools by its suppliers. How well does this new AIG VDA FMEA methodology integrate with the SAE
DRBFM,
Yeah.
design review based upon failure modes.
Yeah.
The one thing about design review based upon failure modes that most people do not remember or miss is the fact that you need a valid, complete DFMEA to start with. So and it is actually DRBFM is a reuse application. So I have a product that I have experience on. I have a valid DFMEA or systems FMEA, and now I'm going to be using it either in a different context or add different functionalities or different duty cycles or whatever. So what that says is that I only need to focus on those particular functionalities on it. So you have the previous baseline or fundamental or family FMEA, and so what you're doing is you're going in there, you're adding in the difference or reviewing it to say with this new duty cycle, does it modify the failure modes or modify the causes on it? So the same way would be if all you're doing is you're updating the initial FMEA that you have worked on.
Okay, and so here's another question. I'll just answer this, Greg.
All right.
What is the expectation of this new format? Folks, the expectations for this new format from the American OEMs, of course, this is a format that'll be accepted by the German OEMs today. And clear expectations on this and how, when it becomes mandatory for US OEMs will become clear. I believe the date was October 2nd when the Quality Summit meeting happens at AIAG. Okay. And
a comment on that. The current CSRs is that, or really
go ahead.
The current says you need to do an FMEA that's consistent with the fourth edition. And consequently, you are free now to use the AIG VDA handbook because that is consistent with it. So there is no limitation. You don't have to wait till somebody to if you want to use it, you can use it. Now the question is, must you use it? We're going to have to wait till information from the OEMs.
So this is a good question, and I wish we had that picture that I could share. It shows what is the relationship between failure mode, effect, and cause at the different levels. Shall I go look for that slide? You know that slide I'm talking about, right? That shows the three different levels and at the three different
I don't know
levels.
if we have time to do that.
Maybe you can just verbally just. What happens is that the cause at the focus level becomes the effect at the
next
next
lower level. Right.
And go ahead.
Right. It's you do have the cascading effect. You have the effect, failure mode, and cause. Well, as you shift down the cause, if you're doing a DFMEA at the cause level, then the cause becomes the failure mode. The old failure mode becomes the effect, and now we have a whole new string of components at the lower level for the cause itself, and those become the causes. So you shift everything down one level, and you can keep on going down until you come to the single part where you end up with just characteristics.
The next question is perfect for you, Greg. We had a consultants meeting maybe a couple of weeks ago, and I had Greg present a paper on the relationship between FEMAs, FTAs, and FMEAs. So a question here, what is the relationship between the FMEA and the FMEA, but you can add also FTA? And why is that important? You can also add to that. I think it's a...
Well, for those of you who don't know what a FMEA is, it's the failure mode effects and diagnostic analysis. It was introduced in its first exposure by 61 IEC ISO 61508. It is to analyze the design with respect to safety mechanisms and diagnostic capabilities. So you identify your particular components, you identify what failure modes, you identify do you have a safety mechanism, so you actually have failure rates in terms of failures in time. And then you come up and you can calculate different metrics. That's defined in 26262. The first part of the FMEA is the same as the first part for the FMEAs. It has the failure modes identified, it has the requirements, or it has the functions identified, failure modes identified, and then that's where it splits. Because in the FMEA, we are looking at the causes and occurrence, whereas in the FMEA, we say what is the failure rate for this particular failure mode, and then look at the safety mechanisms. So they're entirely different focuses. They do start off with the same starting point, but then they go through differently.
And I think you do mention you need to do these for hardware metrics.
FMEA is for hardware
and
only.
FTA. And both the methodologies need to align before you can, say that the hardware metrics are sound.
Yeah.
All right, and then the FMEA will help you identify also hopefully the safety mechanisms for the single fault failures.
Yeah, when you're doing the analysis, most of the analysis in the FMEA specifically, even when it was initially developed, was for electronic elements. because when you talk about safety mechanisms, you most see that most often in electrical electronic components.
All right. So number of questions here. It says Chad mentioned Excel isn't good for new 7-step FEMA. What's alternative ways we can do it? I'll let you answer that. And really, in the end of the day, there's a couple of different software products where people can study and make a decision what works best for them.
Right. That's the key thing. You got to look at your particular organization. How much are you going to be doing? It's not that you cannot use Excel. Excel is just not very efficient in doing it. Chad mentioned that really the handbook approach is a three-dimensional approach because you have the three levels and putting it together in Excel.
Library of functions, a library of requirements at 3 different levels, all linked. How complicated is that?
Right, and Excel does not enable that. You can do that, but there's a lot of redundancies, a lot of re-entry of information in order to use Excel. With that said, if you're only going to be doing one a year, that may be something that you want to look at. There are programs available. Omnex does have a sister company, Omnex Systems, that has a software package that does support. In fact, Chad showed a slide that discussed it, or at least displayed it. There are other companies that have packages that provide support for the handbook, or at least they're working towards it. If they're not, they were developed to do VDA, pure VDA, and they're now being modified. And I have no idea what the status is on there, but they have been modified to do AIAG VDA.
Let's go on, Greg. We have about 12 more minutes. Here is a company. Where did I go with that question here? Any recommendation as to how to split up work between the OEM and the supplier in case a supplier cannot do the system level analysis in your ideal process? What they're saying is they don't think the supplier can do it. Number one, of course, I'll just say this: the customer should not be doing the design, component design. Whoever does a component design needs to be responsible for the design FMEA at least.
Right, yes, that's true.
But if the supplier is responsible for the DFMEA, let me change it a little bit like this. What information should you pass on to the supplier if the supplier needs to do their DFMEA?
The supplier needs to do a DFMEA on their product. Their product is the focus level. You should be giving them the DFMEA on the higher level.
And the focus, your DFMEA's causes are their DFMEA's failure modes.
Yeah.
And their failure modes are your effects. So a good part of the DFMEA is completed when a supplier gets it. What they'll have to focus on is the causes.
Yes. Yeah.
Okay. All right. So this is somebody from ISO 14971 that we all know and love. I'm actually on the medical devices TAG, the US TAG, Technical Advisory Committee. And yes, the ISO 14971 is getting upgraded. And Greg, we're going to be looking at putting in some, especially from the HARA and things like that, into the ISO 14971 so that, best in class in terms of safety can be passed on to products like in the medical device where safety is a big deal.
Yeah, HARA, for those of you who are not into the on it, 4-letter initials is Hazard Analysis and Risk Assessment. It's one of the tools which is discussed in 26262 to identify potential hazards, safety-related hazards in electrical electronic components.
So, Greg, this is a hard question. I have to think about this also. Regarding level analysis, we manufacture semiconductors, so they think of themselves as doing what they call standard products. All right, they're not quite sure who is the customer, but they definitely know who is the supplier. Okay, um, how do we complete the level analysis? Any recommendations?
Yeah, I would say that because the semiconductor, the 26262 would apply to them.
No. This is on AIG VDA FMEA.
Just
All right, sorry. Go ahead.
there. And one of the things that they do, there is in 26262, is have a discussion of a safety element out of context,
Hmm.
which means that if you do not have a customer, you do not have a context, which essentially is the question, I don't have a customer, so I don't have a higher level. Well, then you do the same thing you would do with safety element out of context. You have to make assumptions. You have to say, this is what we're producing something that is going to be going into a battery management system, or we're going to be doing something that's going into the airbag control system. And based upon that, you make the assumptions, and then you complete the FMEA.
So, our company manufactures a coating for vehicles and vehicle parts. How could we use the AIG VDA FMEA? First, let's think DFMEA, and then we can think PFMEA. PFMEA, of course, they can do.
Well, they can
Right.
do DFMEA. That means
Also,
they could
yeah.
do a DFMEA for fourth of the. I mean, they got to do a DFMEA anyway.
For the AIG VDA DFMEA,
Same thing.
same thing, right?
Right.
Yeah.
And so you say, what is the higher level? Well, if I'm going to be doing coding, where am I going to be doing coding?
For a vehicle, the higher level would be the vehicle.
Right.
And the lower level would be maybe the ingredients going into the chemical.
Right.
Right? Okay. So, folks, that it should work quite fine. Here's an interesting question. They think the house of quality, the QFD house of quality, solves the V model. I don't quite see that.
No, I don't see that either.
I don't even see. Well, they do have cascading QFD. I think it's
you turn the V upside down, it becomes complicated. A roof on there.
It's too complicated. The easier one is to just do this. And the big problem is the other side of the V, where the testing.
Yeah.
QFD doesn't really talk about testing at all.
No.
So folks who were sent that question, it doesn't quite work. All right. We'll take on a few more questions that it didn't answer. A lot of questions here. Okay, a lot of software questions. So do you have a trial copy of the software package we can review? Absolutely. Please do contact us, and we will set you up with that. We also had a comment from our, we have a partner in Korea, SPID, and let me just mention them here. Of course, our software is available in all kinds of different languages, and as we speak, it's available in even Thai. It is available in Chinese. It's available in Spanish, and so on. So like that, it's also available in Korean. Well, thank you for one of the that you really enjoyed this. We're getting some of the comments here. Let's see here. You mentioned the 3D model. Okay, any chance that you have a database format? Somebody wants our database format. I don't think we can quite do that. I'm a tier 2 supplier. Then can I stop my DFMEA at component level? Meaning, when there's a component level, the lower level is of course the characteristics. Yes, if you are a component supplier, correct me if I'm wrong, Greg, the AIG VDA FMEA stops at your DFMEA if you're doing design.
Well, you have parts underneath the components.
Unless if it's a component, it's a single part. I'm thinking of the component as a component. It's one component. If it's a subsystem, then of course they'll have to do a DFME at a lower level also.
All right, we're terminology because in 26262 that component does have parts.
So somebody is repeating one of the issues that we talked about, that they're not getting current DFMEAs from the customer. How is that going to change? What types of training are being done with the OEMs? And in many cases, they're actually design related. It seems that the DFMEA is going to be critical to the PFMEA, which has always been, yeah, absolutely right you are, Deborah. And the PFMEA is supposed to link back to the DFMEA. It's not only a AIG VDA issue, it's also a IATF 16949 audit point, okay? So this really, I am hopeful this brings everybody together. How is a software FMEA different from DFMEA? We teach software FMEAs, and the software FMEA, I'm going to say keep to the 4th edition. I have to think some more, but our current software FMEA class teaches the 4th edition.
Yeah.
And yes, is there a relationship between the components? Can you do a system FMEA and then a module? You could do that. Folks, a good question for us. We'll think about it. I haven't thought about it. So Greg, as one of the writers of the MFMEA, the machine FMEA, where does the machine FMEA fit into this as a question?
Well, the machine FMEA is actually a combination of the DFMEA and the MSR FMEA. So if you're going to be going to the handbook, you would actually be doing 2 of them. You would be doing the straight design FMEA for the physical machine, and then you would be doing an MSR FMEA for the warning lights and things that are trying to improve or to catch things from going wrong once the machine is in the field. So that would actually be a combination of 2 FMEAs.
So for embedded software, they're not familiar. They think, can you do DFMEA? Absolutely, folks. For embedded software, right now, the standard that requires you to do DFMEA is if you have safety, is the 26262. Actually, they make it recommended.
ITF says
not for software. Not for software. It doesn't. It just says you need to follow like CMM, CMMI, or ASPICE.
Right.
But let me just tell you, I am actually doing a ASPICE executive overview for an OEM and their suppliers for software. This OEM requires software interface DFMEAs. Yeah, very, very impressive. And I'm yes, absolutely can do. We've been doing it for many, many years. And all right. So yes, for the person who asked me that question, you can always do that. Folks, with that, I think we have taken all your questions, or most of them anyway. I know there's actually questions here and there maybe I missed, but time's up for today. Thank you all very much for joining us. We have 2 more webinars in this series. And of course, folks, we have open enrollment training and on-site training. We have we have executive overviews that we really think your top management needs to know. We have training for implementers, and then we have training for practitioners and facilitators. So with that, thank you from Greg and myself.
Yes, thank you.
Take care, everyone. Bye-bye now.
Bye.